Hello viewers, welcome to our channel Career Prep. In this video, we'll solve a few problems from the topic late, early and usual time. Since questions based on this topic are most frequently asked in competitive exams, it makes sense to understand the concept well. These questions are the ones where marks can be scored easily if practiced well. Before we begin, please subscribe to our channel. Also press the bell icon to get notifications as soon as we post a new video. So let's start. A man reaches his office 20 minutes late if he walks from his home at 3 kilometers per hour and reaches 30 minutes early if he walks 4 kilometers per hour. How far is his office from his house? You're given four options here and you have to find out which of these options is the correct one. Now it's given that if the man walks at 3 kilometers per hour speed, he reaches the office 20 minutes late. If he walks at a speed of 4 kilometers per hour, he reaches the office 30 minutes early. So here you have the times late and early. So to find the difference in time, you have to add these two times. So difference in time is 20 plus 30, which is 50 minutes. Now convert this minutes to hours. So we know that 60 minutes is 1 hour. So 50 minutes is 50 by 60 hours, which is nothing but 5 by 6 hour. So difference in time is 5 by 6 hours. We know that time is equal to distance divided by speed. So in the first instance, where the speed is 3 kilometers per hour, time is equal to d upon 3. In the second instance, where speed is 4 kilometers per hour, time is equal to d divided by 4. We know that the difference in time is 5 by 6 hours. So d by 3 minus d by 4 is equal to 5 by 6. On solving this, we get d is equal to 10 kilometers. This means that the man's office is 10 kilometers away from his house. So the correct answer is option D, 10 kilometers. Lokesh usually reaches his office 20 minutes late. He reduces his speed by 10% and reaches 30 minutes late. How much time does he need to complete the journey on time? You are given four options here and you have to find out which of these options is the correct one. Now here it's given he reduces his speed by 10%, but we do not know his earlier speed. So let's assume his earlier speed was 100 kilometers per hour. So if his speed was 100 kilometers per hour, then Lokesh reaches his office 20 minutes late. Now he reduces his speed by 10%. That is, his new speed is 90 kilometers per hour. So at 90 kilometers per hour, he reaches his office 30 minutes late. Now we have late time and late time. So we have to subtract these two times to get the difference in time. So difference in time is equal to 30 minus 20, which is 10 minutes. Let's convert this 10 minutes to hours. So 10 divided by 60 hours is 1 by 6 hours. So difference in time is 1 by 6 hours. We know that time is equal to distance divided by speed. In the first instance, speed is 100 kilometers per hour. So time is d divided by 100. In the second instance, speed is 90 kilometers per hour. So time is d divided by 90. We know that the difference in time is 1 by 6 hours. So d by 90 minus d by 100 is equal to 1 by 6. On solving this, we get d is equal to 150 kilometers. Now we know that the distance is 150 kilometers and his usual speed is 100 kilometers per hour. So time is equal to distance divided by speed, which is 150 divided by 100, which is nothing but 1.5 hours or 90 minutes. So Lokesh takes 90 minutes to travel 150 kilometers, but if he takes 90 minutes to uh, travel 150 kilometers, then he is late by 20 minutes. So to reach on time, he should complete the journey in 90 minus 20, that is 70 minutes. So Lokesh should complete the journey in 70 minutes to reach on time. So the correct answer is option B, 70 minutes. Walking 6/7 of his usual speed, a man is 12 minutes late to his office. What is the usual time taken by him to cover that distance? You are given 5 options here and you have to find out which of these options is the correct one. Now it's given that walking 6/7 of his usual speed, a man is 12 minutes late. But we do not know his usual speed. So let's assume that the usual speed is v kilometers per hour. Then the new speed is 6/7 of the usual speed, which means 6v by 7 kilometers per hour. We do not know the usual time taken by the man to cover the distance. So let's assume that the usual time is t minutes. Then the new time is t plus 12 minutes. Now here the distance covered is the same. We know the formula for distance is speed multiplied by time. Now at the usual speed of v kilometers per hour and usual time of t minutes, distance will be equal to v multiplied by t. At the new speed of 6v by 7 kilometers per hour and new time of t plus 12 minutes, distance is equal to 6v upon 7 multiplied by t plus 12. But since the distance covered is the same, v multiplied by t is equal to 6v by 7 multiplied by t plus 12. On solving this, we get t is equal to 72 minutes, which is nothing but 1 hour 12 minutes. So the usual time taken by him to cover the distance is 1 hour 12 minutes. So the correct answer is option B, 1 hour 12 minutes. A boy increases his speed by 9/5 of his original speed. By this, he reaches his school 30 minutes before the usual time. How much time does he take usually? You are given 5 options here and you have to find out which of these options is the correct one. Now it's given that by increasing his speed by 9/5 of his original speed, the boy reaches the school 30 minutes before the usual time. But we do not know his original speed. So let his original speed be v kilometers per hour. Then the new speed is 9/5 of the original speed. So new speed is 9v divided by 5 kilometers per hour. Now we are asked to find how much time does he take usually. So let's assume that the usual time is t minutes. Now it's given that with the new speed, the boy reaches the school 30 minutes before the usual time. So if usual time is t minutes, then the new time is t minus 30 minutes. Now here the distance covered is the same. We know that the formula for distance is speed multiplied by time. Now at the usual speed of v kilometers per hour and the usual time of t minutes, distance is equal to v multiplied by t. With the new speed of 9v by 5 kilometers per hour and new time of t minus 30 minutes, distance is equal to 9v by 5 multiplied by t minus 30. Now since distance covered is the same, V multiplied by T is equal to 9V by 5 multiplied by T minus 30. On solving this, we get T is equal to 67.5 minutes. So the usual time taken by him is 67.5 minutes. So the correct answer is option A, 67.5 minutes. In covering a distance of 30 kilometers, Abhay takes 2 hours more than Samir. If Abhay doubles his speed, then he would take 1 hour less than Samir. What is Abhay's speed? You are given 4 options here and you have to find out which of these options is the correct one. So here you are asked to find what is Abhay's speed. So let's assume that Abhay's speed is x kilometers per hour. Now it's given that a distance is 30 kilometers. So distance is equal to 30 kilometers. Now at a speed of x kilometers per hour, Abhay takes 2 hours more than Samir to cover 30 kilometers. It's given that if Abhay doubles his speed, that is if his speed becomes 2x, then he takes 1 hour less than Samir to cover 30 kilometers. So here you have more and less. So you have to add these times to get the difference in time. So difference in time is 2 plus 1, that is 3 hours. Now we know the formula for time is distance divided by speed. Now here distance is 30 kilometers. In the first instance, speed is x kilometers per hour. So time here is 30 divided by x. In the second instance, distance is the same 30 kilometers, but speed is 2x. So time is 30 divided by 2x. We know that the difference in time is 3 hours. So 30 by x minus 30 by 2x is equal to 3. On solving this, we get x is equal to 5 kilometers per hour. So Abhay's speed is 5 kilometers per hour. So the correct answer is option A, 5 kilometers per hour. Due to bad weather, an aircraft reduces its speed by 200 kilometers per hour and reaches 30 minutes late in a flight of 1200 kilometers. Calculate the initial speed of the aircraft. You are given 5 options here and you have to find out which of these options is the correct one. So here you are asked to calculate the initial speed of the aircraft. Now it's given that an aircraft reduces its speed by 200 kilometers per hour and reaches 30 minutes late in a flight of 1200 kilometers. So here we do not know the initial speed. So let's assume that the initial speed is v kilometers per hour. Then the aircraft reduces its speed by 200 kilometers per hour. So the new speed is v minus 200 kilometers per hour. Now at the new speed, the aircraft is late by 30 minutes. 30 minutes means half an hour. So at the new speed, the aircraft is late by half an hour. We know that the formula for time is distance divided by speed. Here the distance is the same. D is 1200 kilometers. In the first instance where the initial speed is v kilometers per hour and distance is 1200 kilometers per 1200 kilometers, time is equal to 1200 divided by v. In the second instance, the distance is the same 1200 kilometers, but the new speed is v minus 200 kilometers per hour. So here the time is equal to 1200 divided by v minus 200. We know that the difference in the time is half an hour. So 1200 divided by V minus 200 minus 1200 divided by V is equal to 1 by 2. On simplifying this equation, we'll get V multiplied by V minus 200 is equal to 4,80,000. Now this equation is easier to solve if we put the values of the speed given in each of the options. In option A, speed is 800 kilometers per hour. So let's put 800 in place of V here. So we get 800 multiplied by 800 minus 200. Now 800 minus 200 is 600. 600 multiplied by 800 is 4,80,000, which is also given in this equation. So the correct value for V is 800. So V, the initial speed is 800 kilometers per hour. So the correct answer is option A, 800 kilometers per hour. An aeroplane is stopped for half an hour and now has to cover a distance of 1500 kilometers in the given time. So its speed is increased by 250 kilometers per hour. Find its initial speed. You're given 5 options here and you have to find out which of these options is the correct one. So here you're asked to find the initial speed. So let the initial speed be V kilometers per hour. It's given that speed is increased by 250 kilometers per hour. So the new speed is V plus 250 kilometers per hour. It's also given that the aeroplane is stopped for half an hour. So the difference in time is 1 by 2 hours. Also, it's given that the distance is 1500 kilometers. Now we know that time is equal to distance divided by speed. In the first instance, D is 1500 kilometers and initial speed is V kilometers per hour. So time is 1500 divided by V. In the second instance, the distance is the same, 1500 kilometers, but speed is V plus 250 kilometers per hour. So time is 1500 divided by V plus 250. Now we know that the difference in time is half an hour. So 1500 divided by V minus 1500 divided by V plus 250 is equal to 1 by 2. On simplifying this, we get V multiplied by V plus 250 is equal to 7,50,000. Now this equation is easier to solve if we put the values of the speed given in each of the options. Now if we consider option A 1000 kilometers per hour and substitute the value of V as 1000, then we get 1000 multiplied by 1000 plus 250. Let's see if that comes to 7,50,000. So 1000 plus 250 is 1250. 1250 multiplied by 1000 is not equal to 7,50,000. So the value of V is not 1000. Let's move on to option B, 750 kilometers per hour. Let's substitute the value of V as 750. So now we get 750 multiplied by 750 plus 250. Now 750 plus 250 is 1000. 1000 multiplied by 750 is 7,50,000, which is also the case in the given equation. So the correct value of V is 750. So V, the initial speed is 750 kilometers per hour. So the correct answer is option B, 750 kilometers per hour. A man covered a certain distance at some speed. Had he moved 3 kilometers per hour faster, he would have taken 40 minutes less. If he had moved 2 kilometers per hour slower, he would have taken 40 minutes more. What is the distance in kilometers? You are given 4 options here and you have to find out which of these options is the correct one. Now it's given a man covered a certain distance at some speed. So we do not know what the distance is and we do not know what the speed is. So let's assume that the distance is x kilometers and the speed is y kilometers per hour. It's given had he moved 3 kilometers per hour faster, he would have taken 40 minutes less. 40 minutes is nothing but 40 by 60 hours. So x by y minus x by y plus 3 is equal to 40 by 60. On simplifying this equation, we get 2y multiplied by y plus 3 is equal to 9x. This is equation 1. Now it's given if he had moved 2 kilometers per hour slower, he would have taken 40 minutes more. So x divided by y minus 2 minus x divided by y is equal to 40 by 60. On simplifying this, we get 2y multiplied by y minus 2 is equal to 6x. This is equation 2. Now on dividing equation 1 by equation 2, we get y is equal to 12. That is, the speed is 12 kilometers per hour. But we are asked to find the distance in kilometers. That is, we are asked to find the value of x. So let's substitute the value of y in either equation 1 or equation 2. We know that y is equal to 12. So substituting the value of y in equation 2, we get 24 multiplied by 10 is equal to 6x. On solving this, we get x is equal to 40 kilometers. So the distance is 40 kilometers. The correct answer is option D, 40. Viewers, please go through this video till you have understood the concept. Practice more such problems to increase your speed and understanding of the concept. Please do watch our video on solved problems on relative speed. If you have liked this video, please like, subscribe and share this video. Thank you.